This is Trading Course Session B, and we have 4 videos. In this session, the first video is on variance. So, what is variance? I was asked that question actually in the Betting People interview from Star Sports, which is available on YouTube if you Google Betting People Tom Brownlee. And it's the third video of 4. Mathematically, variance is the sum of the value of the observed amount minus the mean of all the observed values, all squared divided by the number of observations minus 1. Now, that's mathematically what it is. Okay, so I may have been a little bit flippant with that answer for the balance, but variance is very important in professional betting and value betting. So let's take a little bit of a closer look at it. It is a statistical measurement of the spread between numbers in a data set, and really what we're looking at is how far away from what we would expect to happen could something happen. And I'm going to visualize this with the toss of a coin. So here we have 10 tosses of a coin, and we've done it a lot of times. We've simulated that 17,200 times in this spreadsheet. And this is a toss of a fair coin where it's 50-50, it lands heads or tails, but it's a plus EV bet for you. Because if you win, I'm going to pay you £2. If you lose, you have to pay me £1. You're getting 2 to 1 on your money here. This is a 50% EV bet. In decimal, that would be 3.0 divided by 2.0 equals the EV of this bet, which is 150%. We can take the 100 off because that's how you calculate ROI, equity, expected value. 50%. I've run this 17,000 times, and the outcome is here, and you can see that the average profit is £5. You're putting £10 down, so 50% of £10 is a fiver. So over infinite simulations of these 10 coin flips, you will be on average exactly £5 up. But what about the individual simulations? You see, flipping a coin 10 times the first time, well, you won £8. Let's do it again. You won £5. What about this one down here? You lost £1 on row 30 here. You lost another £1. You lost £4 on row 48. In fact, there are 11 different outcomes of this. We could have all heads, in which case you lose every single one, and you lose £10. Or so that's winning 0 bets, winning 1, winning 2, winning 3, winning 4, winning 5, winning 6, winning 7, winning 8, winning 9, winning 10. And of course, if you win 10, you get 2 times 10 equals £20 from me. Now, this is a fantastic opportunity for you, and yet we see that 0.09% of the time you lose all your money. It's the same amount of time that you will win all your money as well. You will lose £1 11.95% of the time. In fact, if we sum them all up, you will lose 17.26% of the time. I've got a little pie chart here. There you go. 17.26% of the time you will lose. It's a great opportunity for you. And you've repeated this great opportunity 10 times. And yet you've still lost just over 1 in 6 times. And that's quite common. You know, you've rolled the dice and you've lost. And you might think, well, is something wrong here? But this is what variance is. Have a look at the histogram. You can see that the vast majority, the mean, is winning £5, or the mode, if you like, is winning £5. And there's your 80% of simulations where you're going to win money. But down here, this happens more often than you would think. Losing £1, losing £4, losing £7. Okay, losing £10 doesn't happen that often. But this is what we have to get used to. We're doing exactly the right thing over and over again 10 times, and we're still finding that we're losing, and variance can show us how much we are going to lose and how often we are going to lose. And a break-even player can sometimes feel like they're losing more often than they're winning because of a notion called loss aversion. Loss aversion is where a loss feels twice as powerful as the benefit of a game. So we are gaining 50% of the time as a break-even player. We're losing 50% of the time, but those losing times feel harder, especially when we're not recreational. Recreational bettors may be expecting to lose. When we expect to win, that's when these simulations, these times, these experiences that we have where we placed exactly the right bet, huge EV, 50% EV, and we're still losing at the end of it. We have to get used to these losing periods as advantage players. Let's change the simulation. Let's not flip it 10 times. Over here, exactly the same EV bet. I'm going to pay you £2 if you win. You can pay me £1 if you lose. But now we're going to run it not 10 times, but 100 times. Okay? And we're going to run this the same number of simulations. So we're going to run this 17,000 times. What is the difference between running it 10 times and running it 100 times? Well, now we're starting to iron out variance. Here is the outcome here. And whilst statistically it could be possible that you lose all 100, it's actually 2 to the power of 100, which is a pretty big number. That's the odds of you winning all 100 coin flips. In my simulation of 17,000 coin flips, I never saw that happen once. In fact, I didn't even see a £10 loss. I saw a £1, a £4 and a £7 loss. And the pie chart, it's not a histogram, it's a pie chart, but it looks a lot better now. We're now only losing 0.03% of the time. We're winning 99.97% of the time. What did we do to improve this? We just extended out our sample size. We repeated our bet not 10 times, but 100 times. And variance took care of the number of times we were going to profit or we were going to loss out of this. So how many bets is necessary to overcome variance? Well, it depends on a lot of factors, the magnitude of the odds, the EV of the bet. But let's have a look at a blog post under latest news. We have a lot of blogs. And we were looking at win both halves bets. Win both halves is a calculation we do ourselves in-house. So if it's Manchester United to win both halves, we will have a look at the expected goals of Manchester United in different halves, and we will come up with our own price for that. And we push these to the tracker, both in terms of standard market bets and also boosts. And these bets in this blog that I'm talking about, the 1,000 bets, are the ROI, the return from the boosts, benchmarked against our number. We looked at specifically 1,000 before we reported on this. We were asked to report on it after about 400 bets. This was in January 2021. And a user turned to us and said, can we report on the return on investment of win both halves? And I suspect they had been betting on a lot of them and they had not made any money. In fact, by January 2021, the ROI down here was minus 7.5%. That coincided with a dramatic reduction in the quantity of goals through the lockdown period at the end of 2020 and the beginning of 2021. We did wait until 1,000 bets to report on the ROI, and the average odds were 4.91, and this is level staking to win the same amount of liability in every single bet. The profit loss at the end would have been £5,000 from 64,000 stakes, which would have been a return on investment of 8.03%. The expected return on investment, because these were boosted bets that we were monitoring, was 8.37%, so just a little bit under. The member that asked us to report on the ROI after 400 bets unfortunately cancelled shortly afterwards, and so they experienced the losing run of 400 win both halves bets, and that may have been 1 or 2 bets, per day for quite a long period of time. In fact, from the 4th of July 2020 all the way to January 2021. And it was just a very bad bout of variance. And the question you have to ask yourself as a professional bettor is, could you handle that period of time? Could you handle 6-7 months of betting 400 bets in 400 matches and having made minus 7% and sticking with it? Another tracker that we have at Bookie Bashing is golf. In the hub, we've got the results for all of our trackers, and we do monitor the golf tracker. And in the golf tracker, The graph is, well, it looks healthy. It looks like we start with £1,000 and now we have north of £12,000. But this period of 2,000 bets, which is about 8 players per tournament, so we're looking at roughly 250 to 300 tournaments. What we find here is this period here from bet 300 to bet 700. This period here from bet 1300 to bet 1700. Those can last for 6, 9, even 12 months. So imagine that every Sunday night you are following a golf tournament, and for 12 months through January, February, March, April, all the way to December, you look at your bet history and you see in 12 months I have made no money, or I've even lost a little bit of money. The question you need to ask yourself as a professional bettor, as an advantage player, is that expected? How unexpected is it? Can I deal with the variance of betting on bets that are profitable, and yet over a very long period of time I find that I'm either losing money or I'm breaking even? If you want to flatten variance, simply stake lower or more frequently, or both. Over a large sample size, staking lower is going to flatten out the distance that you are from the amount of money that you expected to make. And that counts, of course, in both ways. You will make more, or you will be expected to make less on the profit side of things. However, you will lose less if variance is biting you in the ass. So you can model the variance. You can have a look at this if you know how much you are expected to win. If we go back to the coin flip example, we were expecting to win £5 for every £10 stake there, the 50%. That was the EV. So if we've got a series of bets and we know the EV and we know how much we're staking, we can run these simulations either using Excel or at bookiebashing.net. Under our tools, we have a variance simulator, a variance model that can do the same thing. And we can run simulations of series of bets with different odds and EV. And we can look at how many times, what percentage of times we would expect to break even, we would expect to make a profit, and we would expect to make a loss. And understanding variance under any betting strategy is a key component of advantage play and value betting.